Hello. Hey, I want to get started in a minute. I wanted to let you know that the handout I'm working with is available for download now on my website. The website is streaminglearningcenter.com. And if you can ignore the many pictures of me, scroll down. The top line is codecs. And if you click download handout, if you click the image, comparison of H.264, HEVC, VP9, and AV1, you'll be taken to this page. And once on this page, this link here will lead you to the presentation handout. Okay, so that's available online right now, streaminglearningcenter.com. Okay, let's get started. My primary focus today is going to be on content publishers, not hardware developers. So while we all hate the $60 million plus in royalties for HEVC, that's going to be paid by content developers. It's not being paid, being paid by hardware developers, not content developers. So it's not a huge deal from my perspective. I'm also going to cover the four listed mainstream concepts. Codecs, I want to mention that there are strong business cases for VNova Perseus and Real Media HD, but I'm not going to discuss them here. I'm going to stick to AV1, H.264, VP9, and HEVC. I guess from a theoretical perspective, why do we change codecs, or why do we add a codec? And really it comes down to two things. We do it to make money or to save money. And we make money by entering new markets, whether it's HDR, ultra low bandwidth, 4K, or to improve QoE in existing markets. So if we have happier customers, we theoretically make more money. And the factors in the make money decision is the codec reach, how many platforms does it play on, codec features, and codec quality at a given bit rate. And then save money, we save money by reducing bandwidth costs. And the factors there are, again, codec reach, quality, encoding cost, and some other factors. So when I look at a codec, I want to gauge the reach, I want to gauge the features, and I want to look at the cost side. And cost is always a kind of a trade-off between quality and encoding time. Starting with H.264, and I'm going to have to go through this pretty quickly. I got 60 slides, 45 minutes. But a lot of this stuff you guys know anyway, so hopefully we can really focus towards the end when we get to AV1. But this is from a website called Can I Use? Green is good, red is bad, and we see that H.264 pretty much plays everywhere in computers and mobile. And that's obviously one of the key benefits is ubiquitous playback, which extends to OTT devices and smart TV. It may not be the best codec to play on these devices, but it will play. And if you're looking at live transcoding or live streaming, pretty much every live encoder out there can do H.264. There's transcoding available into multiple formats from Wowza, other services like Nimble Streamer, and many, many cloud software and appliance-based encoding vendors support either live encoding direct to package streams you can distribute, or transcoding in H.264 format. And since there's very little 4K deployed in a live operation, other than the big letter networks, H.264 is still a great option for most live events. I do most of my stuff in either 1080p or 720p. It doesn't make, maybe for contribution, it makes sense to think about HEVC and Teradek's here with an HEVC encoder as is LiveView. But in most instances, I'm going to distribute H.264 to my viewers because I'm not distributing 4K or HDR. And in terms of H.264 and HDR, this is the Dolby spec on the right. There is a compatible version of H.264 Dolby Vision. It's 8-bit, so I don't know how good it looks from an HDR perspective. In any event, most people who are doing HDR are using HEVC. It might be technically feasible for AVC, but it's a better decision to use HEVC at this point. And in terms of the cost side, quality, encoding time, and storage. Quality is the baseline. It's the codec we compare all the others to. Same thing for encoding time and cost and storage. The royalty situation for H.264, there are royalties for subscription and per title. This is nothing new. These are the MPEG-LA royalties that have been in existence for, since the patent pool was launched. And there have been no changes to my knowledge. There was initially some potential for H.264 royalties on free internet video, but MPEG-LA backed off that claim years ago. So if you're distributing free internet video, there are no royalties for H.264. So what else does it cost you? It's costing you capacity. If you're delivering over a fixed capacity infrastructure, according to Netflix, both X.265 and VP9 are up to 40% more efficient, especially at higher resolutions. There's the bit.ly link, you can check that out. So if you're using fixed bandwidth capacity, you could expand that capacity by changing codecs. A lot of people work under fixed capacity, a lot of people don't, so it's not really an issue. We're going to explore the bandwidth costs as we move into additional codecs. It does cost you in quality of experience. So here we have two encoding ladders, H.264 on the left, HEVC on the right. We see the resolution, and then we see the VMAF score. And VMAF is a quality metric invented by Netflix and some academics, and it's kind of the metric that I use for most of my encoding ladder calculations. So we see the res on the left for H.264 and the corresponding VMAF score, and we see the delta on the right, which is the difference between the VMAF score for the HEVC version and the H.264 version. And for perspective, anything beyond 6 should be a just noticeable difference, meaning a viewer who looks at the 365 kilobit per second stream with a difference of 12.61 is going to notice a difference. Correspondingly, down at the 6 megabit per second stream, there's a 0.54% difference between the VMAF score for HEVC and for H.264, and that's not going to be noticed by anybody. Okay, so what did it cost you for mobile? If you're distributing a mobile stream at 1.1 megabits per second, you're going to distribute around 432p for H.264, which has a VMAF score of around 80.81. You can get 720p at pretty good quality at 1.1 megabit per second. That has a VMAF score of around 87. So you've got a 6.72 VMAF score difference with which viewers are going to notice. So if you want to improve the quality of experience to people you're delivering at 1.1 megabits per second, changing to HEVC will do that. Now, how many streams are we delivering to 1.1 megabits per second? If you're in Scandinavia, not too many. If you're in India, that's probably the high range. So it really is going to be a market-specific analysis. And then here's life kind of at the high end in the living room. So at 4.5 megabits per second, it's a little bit high for 720p, but let's use that for argument's sake. The VMAF score is 95.06. If you move up to 1080p with HEVC, you improve about 2.47. Some viewers will notice the difference, a lot of viewers won't. Really, the primary benefit from a quality of experience perspective is going to be in these ranges here. You're not going to see a huge amount of difference between 7 megabits per second H.264, and these are all asterisks. You wouldn't go to 7 megabits per second with HEVC. You'd probably go to 4.5 megabits per second and stay there. So these are all the same. So here's kind of the scorecard. H.264 is great from a reach perspective. It's great from a features perspective. Not optimal from an HDR perspective. Things like low latency, live transcode, all those things are very well supported in H.264. Not so much for some of the other codecs we're going to look at. And then on the quality side, it's kind of the lowest of the bunch. It's what we all compare to. So if you're looking for better quality to given bit rate, this is not the codec that you want to be working with. On the cost side, the low quality means higher bandwidth costs. We'll explore that in a minute. And limited access to low bandwidth markets. If you want to serve in extreme low bandwidth markets like some of the third world countries, H.264 is not the best alternative. And then content royalties are kind of an accepted reality. They've been in place since H.264 started. The big question for H.264 is how much longer will we be encoding? The answer is forever. So pretty much any codec you look at from now on is going to be additive to H.264. Okay, so you're not going to, HEVC is not going to displace H.264, VP9 is not going to displace H.264, even AV1 until 5-10 years from now is not going to displace H.264. You're going to be encoding it forever. Now look at HEVC, same analysis, things start to fall apart immediately. And actually HEVC has improved a lot. HEVC in the last 12 months has been incorporated into iOS, and quite successfully. We ran some tests on that over the last week, and the results were very, very good. So it's in iOS, it's in Android, but it's not in any browser other than Safari and Edge on hardware platforms that support HEVC playback. So if you're looking for a ubiquitous codec to play in a browser, HEVC is not it. On the other hand, if you're looking for a way to reach Apple devices, it's actually quite good. Looking at the HEVC, OTT, and smart TV market, everything I hear tells me that most of the HEVC that's been deployed is in the 4K device spectrum down here. Very little so far in HEVC for HLS, very little obviously for the browser. Most of it is either OTT or smart TV. Apple TV just got 4K support for HEVC in the 4K version. So HEVC is very, very good here, and that's kind of its traditional strength where it plays. In terms of live and live transcoding, you're starting to see a lot of great alternatives for contribution in HEVC. Why do we like HEVC contribution? Because you can cut the outbound data rate requirements significantly if you use HEVC as compared to H.264. And if you're broadcasting over a cellular connection, that can make the difference between a 1080p image and a 720p image. So HEVC is great for contribution. And there's transcoding available both to HEVC and to H.264 streams from Wowza, Nimble Streamer, and then many, many cloud software and appliance-based encoding vendors. HEVC is very, very well supported. If you want to do live either on the contribution side or on the distribution side, it's pretty much available. And then for high dynamic range, as I said before, HEVC is the codec of choice. The cost side in terms of quality, I'm going to throw some rough numbers out here. I mean, I think you can assume the same quality as H.264 is 60% the data rate. So you're going to save 40%. In terms of encoding time or cost, it's really going to vary based upon your encoding platform. If you're running your own encoding farm, the numbers I looked at probably are going to be in the $3 to $6 per hour range for a complete encoding ladder. Could be $20 or $30 an hour if you're paying a third-party service for that, like a cloud provider. If you have your own encoding appliances, it really depends on capacity and utilization. The cost side is going to be more than H.264. I think 4 to 8x is probably a pretty good estimate for very, very large 4K files. And then storage, you're going to save 40% over the cost of H.264 quality, but remember this is all additive, right? Because you're encoding H.264 anyway. So your storage costs are additive, your encoding costs are additive. And then the royalties, this is a pretty familiar mess to everybody. MPEG-LA never had any content royalties. HEVC Advanced started out with content royalties, but then eliminated them in 2018 for non-physical media. Velos appears to want you to get hooked so they can come back and charge you later. They're not ruling it out. They're not saying we're not going to charge it. Their facts continually say we're looking at the situation. We may or may not charge you. And then there's a whole bunch of vendors here who just haven't announced. We don't know what they're thinking other than I'm going to say it was Nokia who just collected $2 billion from Apple in a lawsuit. So we know these guys aren't sitting quietly letting companies use their IP and not getting compensated for it. So here's where we get to the interactive part of the presentation. Please tweet this. I really have no idea what Velos Media is doing. They really could clear up a lot of uncertainty if they just said we're not going to charge content royalties. You know, I've spoken to a number of companies here. Pretty much everybody has said, yeah, one of the major considerations is the fact that we may have to pay content royalties at some point, and that's a concern for us. Why is that a concern? Because this guy cares about uncertainty. And that's just the reality of life that the Velos Media group just seems to be ignoring. Okay, HEVC and HLS, I think, is the biggest short-term decision that most producers need to make. Why do you want to do that? You want to do that for bandwidth savings. Will everybody get bandwidth savings? It's kind of an interesting analysis, and that's what we're going to go through now. Most of the benefit is going to be here from a VMAF perspective. This is where you see you get the major benefit here because you're pushing higher resolutions down into the lower data rate regions. Higher resolutions typically have higher quality than lower resolutions. So you're seeing the most benefit here, less benefit here. So it's going to be most noticeable for mobile. And then the break-even, we're going to look at a break-even analysis. The nature of unverified spreadsheet work is that it's always wrong. So I'm going to present it, and if it is wrong, just email me and tell me why, and then we'll fix it. But the calculation is pretty similar, right? You're pretty simple. You're trying to get to the number of viewing hours necessary to break even if you decide to use HEVC over another codec. And there's two basic parameters. There's the cost side. The cost side is the encoding cost, and also the storage cost, which I kind of ignored because it's so small, divided by the savings per hour if you're paying for your distribution. So it's a pretty simple analysis. I mean, we save X by using HEVC, and that was the 40% number we explored before. We save X by using HEVC or VP9 over H.264. We divide that into the encoding cost. That tells us the number of hours to break even. There's one issue with that, and that's the Netflix ISP Index. And so Netflix, and this is something they publish for every country, every month, and what this says is that the highest throughput that Netflix averages for any particular ISP is 4 megabits per second for Comcast, and that's recent. So, you know, that I think is probably an April number. So that could mean a lot, and we're going to explore that in a second. That could mean that the highest bandwidth you can push reliably to your customers is going to be something lower than Netflix. So, you know, you're not going to push 8 megabits per second. You're not going to push 5 megabits per second. You're going to push 4 or under. You know, your viewers are limited in their capacity to download your videos. So that's one. The other alternative is that Netflix ships a lot of HD videos at 8 megabits, a lot of 4K videos at 16 megabits, and a lot of SD videos at 2 megabits. And if you average that, it's 4 megabits. And they're all going out at the highest possible quality. And if that's the reality, then you are going to save a bunch if you change codecs. And let's kind of look at that in a second. So if you can push 4.5 megabits per second, you've got better deals with your ISPs than Netflix does. If you ship H.264, you're going to use a 720p file. If you ship HEVC, you're going to send a 1080p file. But either way, it's going to be 4.5 megabits per second. So there is no bandwidth savings associated with the change from H.264 to HEVC. There is a quality of experience benefit, but there's no bandwidth saving. Does that make sense? So how do you understand whether you would save money or not? This is a Scandinavian company, and this is kind of the scenario I just addressed for Netflix. So this relates to their 1080p files, and this relates to their SD files, and it was 85% of the files that they are shipping are at the highest possible quality. And even though their average bandwidth was right around 4 megabits per second, that was more a function of the fact that there was that was an average of they don't have 4K, but the average of their 1080p and SD files, than the fact that their bandwidth was restrained to 4 megabits per second. In other words, if they changed these two streams to HEVC, they would save the 40% we were talking about. And if they changed this stream to HEVC, they would change and benefit by the 40% that I was talking about. Does that make sense? Kind of a critical, you know, if you're sending video to a third world country and you're limited to an average of 2 megabits per second or less, and you change to HEVC, you're not going to save a lot of money. You're just going to start sending a higher quality 2 megabit per second stream. On the other hand, if you're shipping the highest quality stream 90% of the time, if you change to HEVC for those streams, you are going to save the money. How do you know? You've got to look at your own log files. And you know, that's going to be market dependent. That's going to be distributor dependent. This is a Scandinavian distributor. They have outrageous bandwidth. I'm working with another Scandinavian distributor whose average customer has 50 megabits direct from his service. So if he switches to HEVC, he's just going to shave a lot of bandwidth costs from the start. But not everybody will be able to do that. And obviously, if you're going to talk about all the bandwidth savings, that's the break-even analysis, right? You've got to save bandwidth to make money. And here's the guaranteed to be wrong spreadsheet. And here's the encoding cost per hour. And 3 megabits is probably the low. That's if you have your own encoding farm. If you're paying a third-party service provider, and this is for an hour of video, HEVC encoded, 11 bitrate ladders, my estimate of cost. Could be off by 20, 30% at the low end, but you know, the numbers should be at scale around $30. And then these are the bandwidth costs, and this is what Amazon is charging in all their rate levels. Long story short, if you're paying $3 an hour to encode your video and your distribution cost is 8.5 cents, you break even in 49 hours of distribution. On the other hand, if your encoding cost is $30 and your distribution cost is 1 cent, it takes 4,100 hours to break even if you decide to change over to HEVC. So again, this might be wrong. If it is, if it looks wrong, just email me and I'll send out an announcement and change the distribution PDF that's out there now. But I feel comfortable the numbers are at least representative. And it's going to be interesting because what's this break-even number going to look like when we look at AV1 and it's 1,000 times more expensive to encode AV1 than it is VP9. And that's on one of the low estimates. So that's where things get kind of interesting. Okay, we did a survey with Harmonic, we being streaming media. We did a survey sponsored by Harmonic in January 2018. This year, with 437 streaming media readers, we basically said, when's the soonest you plan to deploy HEVC and HLS? And 72% of them said they really thought they might be doing it by the end of 2019. So there's substantial interest in supporting HEVC and HLS. And obviously, it starts slow and it picks up. And I think you're going to see a lot of companies doing this. QoE, bandwidth savings. What were their major concerns? Again, Velas Media. 30% rated royalties a concern, which was the most significant of all of these 5 potential concerns. And we gave a class last afternoon on encoding HEVC and HLS. As part of that class, I ran a bunch of tests that involved playback of hybrid manifests with H.264 and HEVC. We had maybe 75 or 80 experiences. You know, you can download that from my website starting probably tomorrow and see what the results were. The Cliff Notes version is, it's very, very good implementation by Apple. We had a bunch of machines tested that weren't capable of HEVC. They just played H.264, no problem. We had a bunch of machines that were capable of HEVC, and they played HEVC with no problem. When there was switching during the startup, they switched from H.264 to HEVC. that was seamless. It was unnoticeable. We had 2 problem streams in the entire group, maybe 70 or 80 experiences, and those were all very, very low bandwidth. So all of the risk that we thought might exist here, the technology risk, I think is very, very limited as long as you're, as long as you're playing to Apple devices. It was very, very impressive. I should say that one of the cool things about the sample files, I'll show them at the end of this class if we have time, is that the codec, data rate, and resolution are burned into the video. So as the video switches up and down, you can actually see what codec was being played, what resolution, and what data rate. And that was quite interesting because it was very useful to see which codec was being played when. But again, long story short, if you're worried about things like battery life, that there wasn't significant excessive use of CPU, there was very little compatibility issues that we saw. It was a very impressive demonstration. So here's the scorecard for HEVC. The big negative is in computers. You're not going to use it to distribute to Chrome, Firefox, and Opera. It's 100% compatible with Android and iOS. It's 100% compatible with smart TVs and OTT. Lots of flexibility here. It's the technology of choice for HDR. Quality is quite good. The encoding cost is, I think reasonable, not a major concern. Content royalty cost, I think, is a potential issue that obviously would be easily cleared up, as I've said a couple of times. And then the FUD factor, fear, uncertainty, and doubt. If you've always got to worry about Nokia saying, "Hey, we want you." If you're a big company. I mean, the average Joe content producer probably doesn't need to worry about that. But if you're a big publisher, this has to be a concern. These two. Because your CFO is going to want to know. Can you say no content royalties? You can't say that because there are major IP owners who haven't designated that. OK, VP9, same analysis. Supported platform side, it's almost kind of the mirror reverse of what you see with HEVC. It's available in all of the major browsers, Chrome, Firefox. It's not in Safari, which is a pretty small number of users, and it's not in iOS. Apple joined the Alliance for Open Media, I want to say in January of this year. I think that probably pretty much assures that they're going to support AV1 on all of their devices as well as in their browsers. And there's a hope, or at least I hope, that they'll also support VP9. That would make life a lot simpler. We also know that YouTube is changing a lot of their 4K videos from H.264 to VP9. Apple's going to want to support them. So if this ever changes, then VP9 becomes a really, really efficient codec for reaching a lot of platforms. A lot of people use, companies like, Netflix is using VP9 for, I think, all of their downloads. They're using it for a bunch of their low bit rate distribution. JW Player here in New York, they're using it for their OVP platform as one of the alternatives to H.264. And once you get, and I think it's the preferred codec for a lot of Android distribution as well. Certainly, it's more preferred than HEVC. Where does it start to break down? It's not an Apple TV. Again, maybe it'll be an Apple TV in the future. And it's not in the hybrid TV spec in Europe or the Smart TV Alliance. So it is in the Samsung spec. It is in these OTT devices. And really, it doesn't feel like VP9 has gotten a lot of the use that HEVC has gotten in targeting these devices. It really feels like this is where HEVC is winning. VP9 is kind of winning in the browser. In terms of transcoding, there are very, very few live encoding devices for VP9 contribution, so it's really not an alternative there. It's got decent transcoding support from services, not as much as you see with HEVC or H.264. But if you want to do transcoding in VP9, you can do it in both the Wowza platform and the Nimble Streamer platform, and there's probably some other platforms that support it as well. Not as well supported as H.264 or HEVC, but it is available. In terms of VP9 and high dynamic range, VP9 is capable of doing HDR video, but as far as I could tell, it's not included in the Dolby Vision spec, and the Apple HLS spec for HDR currently specifies HEVC. So again, HEVC is going to be the preferred technology if you're doing HDR at this point. What's it cost you? You know, it's royalty free, but Google won't indemnify you. If you get sued and you have to pay, you're not going to get money from Google. Google says they performed a full IP review before buying onto, and they haven't infringed since, but you know, our favorite patent pool, Velis Media, says they know that VP9 incorporates some of their technology, or some technology owned by their IP owners. So how many people don't use VP9 because of the concerns like this? I don't know. But it's really hard to assume that Google didn't do their due diligence when buying onto. I mean, they're a very technically sophisticated company. Either way, you know, VP9 is about to be supplanted by AV1 in the next 2 years. If you were going to sue somebody, it wouldn't be over VP9, it would probably be over AV1. That said, if there is an AV1 suit, they'd probably include VP9 as well if the same company was using that. Probably no reason not to. And then from a storage perspective, you're going to get the same benefits as you get with HEVC. So the big question is when to support VP9 in the browser. You know, it's the same QoE and bandwidth savings analysis we looked at a few minutes ago. I'm not going to redo that. With supporting HEVC in HLS, there should be minimal player development costs if you're distributing natively to iOS devices. On the other hand, if you're going to distribute VP9, there will be substantial player development costs you're going to have to include in your break-even analysis. So if you add $20,000 or $30,000 into that break-even, you're going to need more streams to get to break-even, more hours streamed to get to break-even. And then the encoding costs, numbers differ here. I find VP9 a bit more efficient than HEVC, about 2x H.264, depending how efficient the encoder is. Penetration to date, this is from the Bitmovin developer survey. How many people are using VP9? Bitmovin says 10%. And this is from the Encoding.com Global Media Format Report. And this recently came out at NAB. VP9 use is down from, I think it was 11% last year, or 9% to 6%. So in their target customers, VP9 use is shrinking. HEVC is still nascent but growing slowly. And you know, H.264 still dominates. So, and this is why I'm so reluctant to say that a lot of people will switch over. People don't change codecs to save bandwidth cost. You know, VP9's been available for a long time. Netflix has done it. JW Player has done it. JW Player has an exec who came from the On2 team, so it's kind of a hometown favorite kind of thing. So you just don't see a lot of companies making the switch to VP9 to save bandwidth, even though it's playable on all the computer platforms. You just don't see people making that decision. And that's why I think the uptake for HEVC and HLS has been so slow. It really is a QoE bandwidth savings decision as opposed to a new feature decision. If you want 4K, it's got to be HEVC, let's do it. If you want HDR, same deal. But if you want to save money, let's take a look at it. And then the survey, again, the harmonic survey, substantial interest in VP9. Even, you know, this survey took place in late 2017. And then here's the scorecard. So we see, you know, very, very good penetration for computers. Safari is the big missing one here, as is Internet Explorer. It's only supported on the Microsoft platforms and Edge. Mobile with hardware, not supported in iOS devices. OTT Smart TV, it's not in Apple TV, it's not in some smart TVs. Live, it's not a great alternative. Live transcoded, it's okay. Low latency, don't know. And HDR, there's no support in the standard. So it's technically capable, but it's not being used and really isn't available within the standard. What about quality? There's people here from HEVC codec vendors, so I couldn't resist the temptation to talk about the quality of HEVC as compared to VP9. This is the University, or Moscow State University. This is a report they put out in January. This is based upon SSIM, which is an objective quality metric. They found, and let's see, they found that if you looked at the commercially usable encoding comparisons of VP9 and HEVC, VP9 was slightly more efficient, and here's AV1 over here. On the other hand, in this comparison, AV1 I think took 3,000 times longer to encode than either VP9 or HEVC. So that was the trade-off there. The University of Moscow just came out with a new subjective comparison that's based upon their Subjectify.us crowd-sourced viewing program. So this is a subjective analysis that kind of confirmed their objective findings based upon SSIM. So it went from, again, your 65% as compared to 66%. To explain this a bit, 100% is for X.264. So they're basically saying that you can get the same quality as X.264 at 65% of the data rate with VP9, and this is slightly behind it with 66%. So no time. Talk to me later. And you'll see, you'll see 10 of these analyses, and you'll see 10 different results. If it's an academic, they're all going to say HEVC is much better. These numbers are hogwash. VP9 stinks. If you look at what Netflix puts out, who's actually using the technology, they consistently say that that VP9 is 30 to 35% better than H.264. To my knowledge, I don't think they've really compared H.265 and VP9. The work that I've done typically shows that VP9 and HEVC are around the same. You're not going to choose one codec or the other based upon quality. You're going to do based upon some of the other parameters that we talked about. So now let's get to the Alliance for Open Media. What is it? It's a codec produced by, AV1 is the codec produced by the Alliance for Open Media. You see the vendors there. It kind of guarantees adoption within, certainly the browser vendors. You've got Google, Microsoft, Mozilla, Cisco, and Apple. And you've got a lot of content vendors. You've got a lot of hardware vendors that guarantee quick hardware support. And it's a pretty sophisticated group from a technology perspective. And that really, everybody assumes AV1 is going to be challenged in court and the Alliance is going to lose. These are not a lot of technically unsophisticated companies from an IP perspective. The reach, we don't know. I mean, the bit stream was kind of being close to frozen around NAB. I've heard not quite frozen, not quite 100%, but if not then, it will be soon. But in terms of implementation, you've got Apple, Google, Microsoft, Mozilla. That covers operating systems, browsers, mobile operating systems, and desktops. So it's pretty assured it's going to be available pretty soon. It was working in versions of Chrome and Firefox at NAB. One of the major unknowns is we don't know the CPU horsepower required to play AV1 yet. So even though it plays, we don't know if that was the fastest workstation possible or if that was on a cheap laptop. So we don't know what the playback requirements are for AV1. The adoption timeline, this is from the Alliance for Open Media presentation just before NAB. It's going to be in browsers soon. Optimizations of encoding and playback in 2018, 2019, some GPU accelerated versions in 2019, and total hardware decode in 2020. So when will hardware with AV1 decode be available? Probably not until 2020. Why? Because it takes a year for chips to be developed, and then takes a year for hardware products based on those chips to be developed. So you're really looking at, no AV1 on devices like this in hardware until 2020. What's AV1 give you? These are numbers from Facebook. Same quality as VP9 at about 70% of the bandwidth. That's pretty good. It aligns pretty closely to what we found with Moscow State University. What does it cost you? It's as much as 10,000 times slower than H.264. I mean, the Facebook numbers were staggering. I mean, just staggering in terms of how long it took to encode their test files. What does that do to your break-even analysis? So here we have $3 an hour to encode, and we see 417. And I'm encouraged that this number is 1,000 times more than that number, but still, spreadsheet's never right. But if we jack that by 1,000 times, these numbers are still reasonable for YouTube, Facebook, Netflix, Hulu, and some companies who distribute in those volumes, right? And this is kind of a worst case analysis. I mean, this is 1,000 times. Let's say if it's 500 times or 200 times, which a lot of people think it'll get to 100 times or even 10 times by the end of 2018, then the numbers, you start making money a whole lot sooner. But I wanted to show that, this is kind of a worst case analysis, and it's still pretty reasonable for a lot of companies who are shipping videos in that volume. I mean, how many people watch Game of Thrones? Certainly more than this, certainly a whole lot more than that. Is the 30% better quality real? I think anybody who cares at this point is doing their own analysis. I mean, Netflix has been working with it forever. Facebook, same deal. I mean, if you're in that ballpark in terms of volume, then you've already been working with it. You don't need anybody to tell you what the quality is. You've drawn your own conclusions. It's really early now. There's very few production encoders, if any. Nobody knows what it's going to look like from an encoding time quality perspective. So from where I sit, I'm just not going to look at anything for 12 months, because I think they're going to change dramatically from an encoding time perspective and a quality perspective, and I'll kind of revisit it then. There are already 3 or 4 out that just vary so widely, it's not even worth digging into. Not only because it's preliminary, because you're not going to make a decision based upon factors like that. It's really going to be more of a business decision. How much money does it save me? Where's the reach? Things like that. What features does it have? Not going to be strictly a quality analysis. Besides encoding time, what does AV1 cost? Here's Velis again. AV1 is going to be royalty free, but Velis says on their FAQ, it may incorporate patent technologies from many parties. And I'm not sure you want to sue the Alliance for Open Media, because there are a lot of pretty well-funded companies with sharp legal teams on the defense side. So who's going to sue the Alliance for Open Media? One of the announcements that the Alliance made at NAB was they established a defense fund. So even if you're a small company who uses AV1 and you get sued by Nokia or some other IP owner, there's now a defense fund that you can get to. Obviously, these companies can all afford to pay for their own defense. But I think anybody who thinks about suing the Alliance for Open Media has to be thinking about these guys. And that's a big deal. They have pretty much unlimited funds. On the other hand, Nokia just got $2 billion from Apple, and that pays for a lot of hours, even for expensive IP attorneys. So, who knows what's going to happen. What did our respondents say? Lots of interest in AV1. It was the highest, at 33%, it was the highest of all the codecs that were selected. What were they concerned about? They weren't concerned about legal issues. They were concerned about encoding-related and performance-related concerns. And these are the issues that will be resolved over the next 12 months. So, unless you're one of the companies on the front panel of the smart TVs you see at Walmart, with the players already on the TV, which is, again, Netflix, Hulu, YouTube. Unless you're one of those companies, I think you can kind of put the AV1 decision away for a while. Final scorecard, it's going to be in a lot of browsers in 6 months or so, but we're not going to know what the CPU requirements are for a while. 2 years for mobile, 2 years for smart TVs and OTT. And since most of the people doing 4K are targeting these, that kind of makes it a little bit less important to do it right away. In terms of features, Bitmovin showed live encoding with AV1 back at, I want to say NAB last year, 2017, but the encoding requirements really went up in the last 12 months. So I don't think you're going to see live encode for contribution, live transcode, even with FPGAs, for a while. And then HDR, again, that's a hardware decode. You're not going to see that for 2 years. We like the quality. I'm thinking HEVC-like quality at 70% the data rate. The encode time is obviously a major consideration. Content royalty cost, there is none. It's a royalty-free compression technology, but the FUD factor, fear, uncertainty, and doubt. Are you going to get sued if you use AV1? You got to talk to that steely-eyed CFO we saw a few minutes ago and tell him, yeah, that's kind of a concern. And we're out of time, no questions. No, sorry, it's I broke a tooth last week, and they couldn't do anything with it. So it's literally, the more I talk, the worse my tongue feels. So I talked for 6 hours yesterday. So no long questions. I may just go. Anyway, go ahead. Is anybody, sir? Did you have a question?
Yeah, regarding the transition from H.265 to H.264 on the Apple devices, does this mean that the fragments need to be GOP synced between various codecs?
Yes. So the question was, if you're distributing a hybrid presentation with HEVC and H.264, do you need to sync the GOP sizes of the two codecs? And the answer is yes. We use 2 seconds and 6 second segment size.
Is the understanding that Chrome and Firefox are never going to have HEVC?
Good question. Is the understanding that Chrome and Firefox will never have HEVC? I did a bunch of interviews at NAB, and I interviewed 2 engineers from the Mozilla encoding team. And the last question I asked was, when will Firefox support HEVC playback? And understand that Firefox doesn't have to license HEVC to support HEVC. They can borrow HEVC playback from the operating system, and it's available in both the Mac now and a lot of Windows PCs. And he still said, hopefully never. And so, what that means, we don't know, but I predicted when Apple incorporated HEVC into Safari and iOS that Chrome and Firefox would have HEVC playback via the mechanism I just described by mid-year this year. And everything I hear from Firefox and everything I hear from Google is that that's not going to be the case. They're going to resist it till the bitter end. Okay.
Great presentation.
Thank you. It's really hurting.
Yeah.
It's really.
My clarification question was the VP9 encoder, is that libVPX? It was unnadal. It was just labeled as VP9.
Which specifically was the VP9 encoder? Those were just rough estimates. I didn't, or I'm sorry, for the. I'll have to ask. I'll have to look at what. I think it was, yeah.
And then one question is, would you agree that if the customer moved to VP9 today, they would get 70% of the benefits of AV1?
Would I agree if somebody switched to VP9 today, they'd get 70% of the benefits of AV1? I'd have to. I'd have to think through it, but of all the companies in the industry, I really trust Netflix the most in terms of looking at what they do, and they have adopted VP9 for a bunch of different distribution types, and a lot of companies haven't, right? I mean, MLBAM basically says we're going to stay away from it, but Netflix really dove into it, and they're leveraging it, and they're optimizing it. So, but again, I just don't see a lot of companies adopting new codecs to save bandwidth. Companies have resisted that for VP9. They resisted it for HEVC. As much as I've been pounding that drum for 3 years now with VP9. JW Player did it two or 3 years ago, and you just haven't seen. You still see the numbers for BitMove and Encoding.com surveys. So don't see a lot of adoption for bandwidth savings.
If you were to figure out what the closest thing to a kind of a flash universality that we used to have might look like in a year or 2 or 3, what does that look like? Because it doesn't sound like there's either one that seems to be the one that's going to dominate, and seems like they're pretty dead set against ever
So,
updating, so where does this end up anymore?
so do we ever see a single codec that has the same penetration as H.264 did in Flash? I don't think so. You know, I think you're going to see Apple jumping into the AV1 camp has potential implications that I don't think anybody has really figured out yet. And looking at 2 years until we see AV1 implementations kind of really on the playback side kind of makes me very hesitant to kind of guess. I see people using HEVC for smart TVs and 4K, and also I think more and more for playback in HLS. But beyond that, I don't really have any predictions.
Just to follow up, would you feel like the best solution for universality for those of us who are just kind of in the trenches, used to use Flash folks, is HEVC out and then HLS transcoding?
You mean for live or for?
Yeah, for live, in order to be able to be seen by everyone.
Yeah, I think HLS out for contribution is a great strategy, and I think transcoding to H.264, unless you're 4K, you know, is probably a good strategy as well. Okay, we got to wrap up. Let me take 1 or 2 more questions if there are any. That's it. Thanks very much.